Welcome back, Year 11, to what is a very important lesson with regards to logarithms, but it also can be a lesson that can be a little bit tricky because you've got to try and remember some laws. So we know that there are a whole lot of laws for indices. There are 3 laws for logarithms that we're going to be using regularly, but there are also some other little tricky expressions that we need to know as well. So let's go about looking at our laws. Law 1. If you have the log to some base of 2 things that are being multiplied together, you can write it as a log to the base a of each part and add them. So for example, if I had log to base 3 of 5 times 2, that's the same answer as the log to base 3 of 5 plus the log to base 3 of 2. And I'm not going to do the proof behind it, but you think about going back to your laws of indices. Remember what happens when you're multiplying indices? When you're multiplying, you add the powers. So there's the link. When you go to law number 2, if you have the logarithm to some base of something divided by something, you can write it as 2 separate logarithms with a minus. So an example might be if I had the log to base 8 of 7 over 3. I could do this as the log to base 8 of 7 minus the log to base 8 of 3. And our final law is if we have a logarithm to a base and there's a power above it, the power can go out the front. So what that is saying is something like this. If I have the log to base 5 of 3 to the power of 4, I can take that 4, move it out the front. So it becomes 4 log to base 5 of 3. If we go back and we try and remember our laws for logarithms, remember when I was talking about a logarithm as a power? What power do you put above a so you get an answer of a to the power of x? Well, you'd put x above it. So that's an important thing that we need to remember. And if I actually take this expression here, I could actually also end up with this expression here being true. Look at this one here. This is written in index form, even though the power is a logarithm. If I slide the base, I end up with log to base a of x is left over, because that's the base that slides across to the other side, equals log to base a of x. Oh, they're equal in other words. So if you see a logarithm with an index with a power, the answer is the power. If you see an index form raised to a logarithm to the same base, the x is the answer. A really useful little trick that you use for tricky questions down the track. All right, let's get into some examples. So the first one, let's simplify log to base 5 of 5 to the power of 6. Well, straight up, we can see the base is 5. The base of 5 to the power of 6 is 5, so the answer is 6. What power do you put above 5 to get an answer of 5 to the power of 6? You put 6 there. Part B, 4 to the power of log to base 4. As soon as you see that, the answer is 21. You could slide the base to both sides. You set up an equation, slide the base, you get the answer 21. Now, these types of questions are a little bit trickier because they're going to involve you using our log laws, but let's see how we go. Now, the log to base 5 of 12 can be considered as the log to base 5 of 3 times 4, because 3 times 4 is 12. But we know that if we're timesing logarithms, that I can actually write now this as log to base 5 of 3 plus the log to base 5 of 4. That's using the first law of logarithms that we looked at before. Now the log to base 5 of 3, if I look up here, the log to base 5 of 3 is about 0.68 if we round it off. So we're going to say it's about 0.68 plus the log to base 4, the log to base 5 of 4 is 0.86. So I can say plus 0.86. And if I add those two together, I'm going to get 1.54. So that's the process that we're going to follow. Let's see how we go on the next one. Log to base 5 of 9 could be thought of as the log to base 5 of 3 times 3. I'm going to do it slightly differently. I'm going to think of it as the log to base 5 of 3 squared. Now if you think of it like that, there's a power, and the power can go out the front, which means it's the same as 2 times the log to base 5 of 3. But I know the log to base 5 of 3 is 0.68. So it becomes 2 times 0.68, which is 1.36. Let's try part C. Now this is a bit trickier, 0.75, but if you convert 0.75 into a fraction, 0.75 is just 3/4. And if I think of it as being the log to base 5 of 3/4, I can break it up into two parts because there's a fraction of 3/4 there. I can think of it as log to base 5 of 3 minus the log to base 5 of 4. But the log to base 5 of 3 is 0.68. It is there. The log to base 5 of 4 is 0.86. So it becomes 0.68 minus 0.86. And if you put that into your calculator, 0.68 minus 0.86 is equal to minus 0.18. Part D. Now, log to base 5 of 60. This is a bit trickier, this one. A lot of people miss out on this trick until it's explained to them. Now, if I look at 60, it's actually 3 times 4 times 5. Because 3 times 4 is 12 and 12 times 5 is 60. Which means if I use my logarithms law, I could say this is now the log to base 5 of 3 plus the log to base 5 of 4 plus the log to base 5 of 5. Now, 2 out of those 3 I know quite easily. Log to base 5 of 3, I know. Log to base 5 of 4, I know. So I'll put those in. Log to base 5 of 3 is 0.68. The log to base 5 of 4 is 0.86. But what is this log to base 5 of 5? Well, we actually do know it. What power do you put above 5 to get an answer of 5? You put a 1. Which means when I add those 3 things up now, I will get 2.54, and there's my answer. So they're quite tricky little processes, those ones. Let's use our logarithm laws to expand these statements. So log to base 4 of 5 plus log to base 4 of x cubed. Because we need to remember that 5x cubed is 5 times x cubed. And when I look at this particular question, it becomes a log to base 4 of 5 plus 3 log to base 4 of x. Because if you have a power, it goes out the front. Let's look at part B. This becomes the log to base 7 of 7 minus the log to base 7 of x. Because when you've got a fraction, you can do each part separately and minus them. But we do know the answer to this part here, the log to base 7 of 7. What power do you put above 7 to get an answer of 7? You put 1 above it. So you get 1 minus log to base 7 of x. Time to do some questions. Enjoy the experience as always. Bye for now.